little different with the headset, trying to kick the mic over to the side. Because I realize this is just a side note, but every time when you watch the video, you can hear me breathe into it, which isn't bad, but I would get annoyed of it after a while, or having to try to tune it out. What would be really nice is invest in one that's, what is it, the micless one that sits behind your ears. But either way, hopefully this will be a little bit better, so it's not directly breathing into it the whole time. Yeah, but we're going over the review sheet today. We're going to get through about half of it today. We'll do the other half tomorrow. The full video is already on YouTube. I posted it last night, so it's there if you need it. The first thing we're looking at is direct inverse variation, or neither. Direct variation. There's a few versions of it. Y equals a times x. X is equal to a times y. Or we have that a is equal to x over y, or a is equal to y over x. And really, these are all just different arrangements of the same equation. And a is just a number, a constant term. Inverse. Y is equal to a over x, or x is equal to a over y, or x times y is equal to a. Now, there are less arrangements for inverse than there are direct, and that's mainly due to the fact that direct variation is the x over y, y over x is different. Kind of a setup, and sometimes we need to see that to be able to know the difference. I know. Unfortunately, I didn't stun him either, so. Yeah. We'll see if he starts messing with the board again in a minute. But, so our a is equal to x over y, a is equal to y over x, so we have two different, they look different, they are essentially the same thing. But with inverse, x times y equals a is the same thing as y times x equals a, so we don't have to rewrite it twice. But for the most part, for 1 through 6, we're just really matching this up. Which one looks like the others, and that's what it's going to be. Now, neither is kind of nice because there's one or two things that kind of give it away. One main thing is if it has addition or subtraction, it is automatically neither. And looking at these here, well, number 3 is neither. Any others? Number 6 is neither, and we can immediately tell that because of our addition or subtraction, one or the other. Now, we didn't state this one, but this is also a case of neither. Why would this be neither? It's missing one thing. Why? Because for it to be direct or inverse variation, we have to have x and y, and it's so simple we normally skip it. But if it only has one variable, x equals a number, y equals a number, there is no x, we're only given y, or there is no y. If there's no x, we're given y, or if there's is a y but not an x, if we only have one variable, it is neither. We've got to have two. So hopefully those kind of neithers will be easy on the first part. Now, let's go through and say whether the rest are direct or inverse. Number 1 would be direct. Number 2, inverse, because we're just matching it up to the general types for each one. Number 4, inverse. because we do have a variable in the denominator and one in the numerator. Number 5. It would be inverse. Because 2 and 5 are essentially the same, and we have those variables multiplied together on the same side as inverse. Questions on these here? We feel comfortable with these. And especially I would have the different forms of direct and inverse written out. That way we can compare them to them on the test. 7, 8, 9. Not on the test. We're not even going to look at them. I did one in the full review video just to show you guys how they worked again. But they're not going to show up, so there's not a whole lot of reason for us to spend time on them. This next part is to simplify. We need to factor the numerator and denominator as far as possible, and then simplify what's in common. So on the first one, 2x squared over 3x squared minus 4x. 2x squared, can we factor it? Yeah. 2x squared at the top of this fraction. No, because we have one term. When it's by itself, that's not factorable. The denominator, 3x squared minus 4x. How can we factor it? We can factor an x out. There's a greatest common factor. Whenever we're looking at factoring, greatest common factor is where we should start. And it's not so much have a tendency to skip it. It's just after a certain point when we look at them, we're able to tell if they are factorable or not. We can tell a little bit easier if they are or not. So we don't have to worry about that. Question on this so far? Okay. Now we need to simplify what's in common on top and bottom. And what is in common on top and bottom of this here? X. So we can cancel an x out on top and bottom. The one on bottom cancels out completely, and we only remove one of the ones on top. So we are left with 2x over 3x minus 4. And as much as we want to simplify the 2x and 3x or the 2x and 4, we can't because of the minus sign between the 3x and 4. The 3x minus 4 is a single term. And since there's nothing else in common on top and bottom, that is it. Questions on that there? We feel good with that there. Let's look at number 11, 32x squared minus 50 over 4x squared minus 17x plus 15. The denominator, the bottom of that fraction, is there a greatest common factor between our 4x squared, 17x, and 15? No. Is there a greatest common factor on top? Two is, yes? We can factor it out, because that reduces 32 to 16x squared minus 25. Even if you're not sure if there is a greatest common factor or a common factor bigger than 2 for the numerator, if there is one you see for sure, pull it out, then check again. Because we can factor the 2 out, which gives us 16x squared and 25. Is there another number that goes into 16 and 25? No. So that was the greatest common factor. And the reason I say that is instead of trying to sit there and spin your wheels for trying to find other factors, if you find one that is for sure, pull it out and then go from there. I do. All right. So again, kind of had a pause there. That way we pull it out, and if there is another common factor that was left over between 16 and 25, which there's not, we would be able to see it and move from there. We can do it one at a time. Now the denominator, 4x squared minus 17x plus 15. No greatest common factor as we stated already, but there's a good chance that it is factorable. Now we go through our steps. Since the third term is positive, the signs are the same and match the sign of the middle term. Minus and minus. 4x squared. Well, we'd have x and x. And we need to see what's going to factor for 4. Well, it's 1 and 4 or 2 and 2, yes? Well, I'm going to go with 4 and 1. Factors of 15 are 1 and 15, 3 and 5. I'm going to pick 5 and 3 out of all these here. Now, it seems like an odd way to set this up, but if we check this here, 4x times negative 3 is negative 12x. Negative 5 times x is negative 5x, giving us negative 17x. Well, the middle term is indeed negative 17x, so that does work. Now also, well, any question on this here before we finish factoring the numerator? Now the numerator. (16x squared and 25). Well, 16 is a perfect square, yes? It's 4 and 4. 25 is a perfect square, which is 5 and 5. So we'd have 4x plus 5 and 4x minus 5, yes? That gives us something in common on top and bottom. 4x minus 5 and 4x minus 5 will cancel, leaving us with 2 times 4x plus 5 on top over x minus 3. Now, if we wanted to, we didn't have to necessarily take that one step at a time and factor the denominator first before finishing off factoring the 16x squared minus 25. We could have factored 16x squared minus 25 and then factor the denominator and try to use those like terms. What's going to be in common to simplify out? Questions on this here? We're not going to look at 12 mainly because x cubed minus 27. We're not going to have sum or difference of perfect cubes show up. So we'll move on to 13. X squared minus 4x minus 12. And x squared minus 4. Which one do we want to factor first? X squared minus 4x minus 12. Now there is no greatest common factor. There's no number or variable that will go into all three terms. Now since we do have an x squared term and a number without a variable, we'll do our two sets of parentheses with 3 spaces. Since the third term is negative, our signs are opposite, positive and negative. Factors of x squared are x and x. Factors of 12 are 1 and 12, 2 and 6, 3 and 4. Which one do we want to try first? 3 and 4. And we can check this here. X times negative 4 would be negative 4x. 3 times x would be plus 3x, giving us negative x. Is that the middle term we wanted? No. We can switch the 3 and 4. But all that would do is turn it from positive or negative x to positive x. So what do we want to try next? 2 and 6. Okay, 2 and 6. We'll put the 6 first, 2 second. And if we check this here, x times negative 2 would be negative 2x. 6 times x would be positive 6x, giving us a positive 4x. Correct number, wrong sign, so we flip the signs, which would give us the correct setup. Yes? The denominator, x squared minus 4. No middle term, no greatest common factor, but x squared and 4 are both perfect squares. And since they're being subtracted, it is a difference of perfect squares, which would be x minus 2 and x plus 2. Question on how we factored any of this here. Well, now we do have something in common on top and bottom, yes? X plus 2 and x plus 2. Those would simplify out, leaving us with x minus 6 over x minus 2. Now, we're not going to have to list the restrictions. I'm not going to make you list the restrictions on these here. For addition, subtraction, multiplication, division, you just need to simplify. Perform the operation and simplify. Questions on any of these so far? We're ready for the next one. Perform the operation and simplify if needed. 14, I did do 14 on the full video. We're not going to do it here, mainly because that one doesn't show up on the test. We are going to have multiplication. It's just not going to be single terms. We're actually going to need to factor, like number 15. Where we have expressions that are factorable and then multiply, we're going to do that there. If one of the expressions is already given to us in factored form, our sets of parentheses, there's no reason to multiply it back out. Leave it in factored form. I've set some of them up that way just to make it easier on y'all. You don't have to factor everything out. Some of the things are already factored. Now looking at this here, there are two parts of this that are already factored, the x minus 1 and 2x. Those are already in factored form. Now our numerator here, x squared minus 4x. We don't have a term without x, but our x squared and 4x do have a greatest common factor of x. So we can factor out. And when we factor it out, it leaves us with x times x minus 4. Now our last part is our x squared plus 3x minus 4. Since the third term is negative, our signs are opposite, positive and negative. Our factors of x squared are x and x. Those are the only factors of x squared. Then our factors of 4 are 1 and 4 or 2 and 2. So far we haven't had anything in our parentheses that matches up. And the only thing in the denominator that we can line up with is x minus 1, yes? So if we're going to have something line up, it'd be nice if one of those factors is x minus 1. We do have 1 and 4, yes? And it works out that x plus 4 times x minus 1 are the correct factors. Now at this point, we can multiply this together. And we multiply together, we have x times x minus 4 times x plus 4 times x minus 1 over 2x times x minus 1. Greatest common factor on top and bottom would be and there's one other thing. That would be our x and x. Would simplify out. And the x's simplify out because they're out in front. They're being multiplied by the whole thing. It's a little different than our x minus 4 and our x and the x plus 4. But that's it there. Any questions on any of this here? Get ready for the next one. X squared plus 3x minus 4 over x squared plus 4x plus 4, and our x squared minus 4x plus 3, and lastly we have 2x squared plus 4x. Now our 2x squared plus 4x has a greatest common factor of what? Yes? What else? 2. Because 2x squared 4x does have a greatest common factor of 2x. And when we factor it out, we get 2x times x plus 2. Now our other three expressions that we have to factor, none of them have a greatest common factor. So we can't factor that out, but we can still factor with our two sets of parentheses in all three spots. Doesn't matter which one we'll do. First, let's do x squared minus 4x plus 3. Since the third term is positive, our signs are the same and match the sign of the middle term. Only factors of x squared are what? And x. What are the factors of 3? And that's it. So we plug them in, and that is the correct set of factors. It will give us negative 4. Well, now we can move on to the other one. We'll do the numerator, x squared plus 3x minus 4. Since the third term is negative, our signs are opposite. Factors of x squared are x and x. And factors of 4 are 1 and 4, or 2 and 2. Well, 1 and 4 might work a little bit nicer. And we want the 1 to be positive or negative. And we can check this setup here and just make sure this would actually give us negative 4x plus x, which is negative 3x. So we actually need the signs switched. But also in this setup, do we have something in common on top and bottom? The x minus 1, yes? So having it negative is helpful. So we line those up. And the last one, x squared plus 4x plus 4. Since the third term is positive, the signs are the same and match the sign of the middle term. Factors of x squared are x and it. Factors of 4 are 1 and 4, or 2 and 2. Well, x plus 4 is nice on top, but we actually need 2 and 2. Because 1 and 4 in this, if we set it up that way, would give us a middle term of 5x instead of 4x. 2 and 2, 2 plus 2 would give us 4. Questions on any of this here? What's in common on top and bottom? Anything else? No. Because 2x isn't going to simplify with anything on bottom because we don't have any single terms or terms without addition or subtraction. And our x plus 4 on top does not match up with either our x plus 2 or x minus 3. So 2x times x plus 4 over x plus 2 times x minus 3 is our final answer. Questions on 16? Let's look at 17. Well, 17, the other denominator would be 1. Now we just need to factor. Now the easiest one to factor, I believe, is our x squared minus 16. There is no greatest common factor between x squared and 16, and it is a difference of perfect squares. Because we would have x and x, our signs would be opposite, and 16's factors would be 4 and 4. We have x plus 4 times x minus 4. So hopefully in the numerator we would have an x plus 4 or an x minus 4. Those other denominator would be 1. I'll go on and factor x squared minus x minus 12. Since the 12 is negative, our signs are opposite. Factors of x squared are x and x. Now factors of 12 are 1 and 12, 2 and 6, 3 and 4. 3 and 4. Now since the middle term is negative, we'll probably want the bigger number to be negative. And it does work out here that x plus 3 times x minus 4 does give us the correct answer. If we wanted to check, we could do that by distributing out. X times negative 4, negative 4x. 3 times x is plus 3x, giving us our negative x middle term. Well, we already have something in common on top and bottom, yes? x minus 4 and x minus 4, we can go on and remove it. There's nothing that says we can't do it now, especially if it's already on top of itself. Now in the other parentheses, x squared plus 2x minus 8. 8's negative, so our signs are opposite. The only factors of x squared are x and x. Factors of 8 are 1 and 8 or 2 and 4. 2 and 4, because we still could have something line up, yes? And that's with the 4 being positive and the 2 negative. If we check this here, we'd have negative 2x plus 4x giving us a positive 2x like we wanted. Now when we multiply, we're really just sticking the numerators together and the denominators together, which gives us one more set of like terms, our x plus 4 and x plus 4, leaving us with x plus 3 times x minus 2. Now if the denominator reduces to 1, simplifies out completely, we don't have to write it. But if the numerator simplifies out completely, we do have to write that 1. Because we have to write the 1 when the numerator simplifies, but the denominator doesn't. And we do not have to write the 1 if the denominator simplifies out and the numerator doesn't. But if everything simplifies out, it reduces to 1. We're not going to look at 18, we'll look at 19. But division is essentially like multiplication except for one main change. Keep, change, flip. Keep, change, flip. When we divide two rational expressions, we keep the first one the same. We change it from division to multiplication and flip. Flip the second. And whenever we come across the division problems, there's going to be at least one. Keep, change, flip first. Now it might be nice and it's already completely factored. Sets of parentheses on top and bottom for both. And once you keep, change, flip, simplify. Now, our x squared minus 3x minus 40, there is no greatest common factor. Since the third term is negative, our signs are opposite. Factors of x squared are x and x. Now factors of 40 are 1 and 40, 2 and 20, 4 and 10, 5 and 8. And it's going to work out that it is 5 and 8. For time's sake, I'm just going to go on and give it to you. We have this here. Now the denominator of the first one, there is no greatest common factor between x squared, 8x, and 20. But since the third term is negative, our signs are opposite. Only factors of x squared are x and x. Our factors of 20 are 1 and 20, 2 and 10, 4 and 5. But for this one here, we need positive 10 and negative 2 for this to work. Now we're going to go over to our other numerator, two sets of parentheses with 3 spaces, because there is no greatest common factor. Since our third term is positive, the signs are the same and match the sign of the middle term, plus and plus. Factors of x squared are x and x. And our only factors of 20 that we want are 2 and 10. Now, the last thing we need to factor is the other denominator. Since the third term is positive, our signs are the same and match the sign of the middle term, plus and plus. Factors of x squared are x and x. And again, we have the factors of 40. But ones that are going to be nice again are 5 and 8. Because when we multiply them together, we would get something in common. That's the same reason we use 2 and 10 again for the other numerator. Now here our x plus 5 and x plus 5 will cancel. X plus 10. X plus 10 will cancel. leaving us with x minus 8 times x plus 2 over x plus 8 times x minus 2. And as much as we want to cancel these out, they're not the same because the signs in the middle are opposite. And we can't just change it because both signs aren't different. Because if it had been negative x minus 8 on top, we could factor that negative out and make it be the same. But that there is the final answer for that one there. Questions on this here? We'll definitely have time to finish these two here. We'll see where we're at. But whenever we add or subtract two rational expressions, if the denominators are the same, doesn't matter what they are, if they are the same, we can add or subtract. And if they're factorable, we'll need to factor it, but these two here and all the ones on the test where the denominators are the same, we won't need to. Now 20, the denominators are both 2x minus 1. 2x minus 1 is not factorable. But our numerators can be subtracted because the denominators are already the same. And since we only have one expression in each numerator, we don't necessarily need the parentheses. It's not going to change anything with or without them. Our numerator is factorable. Whenever we have two things being subtracted, one has a variable being squared, the other doesn't, we need to check for difference of perfect squares. 4x squared is a perfect square. It's 2x and 2x. Plus minus 1's a perfect square. It is 1 and 1. Now that does give us something in common on top and bottom. 2x minus 1 and 2x minus 1. And what that leaves us with is 2x plus 1. And that's the final answer. And our next one, we do have three things being added together, but all their denominators are 3x plus 2. They're all the same. So we can go on and just add the numerators. And whenever we add the numerators, we don't need the parentheses because we don't have to worry about a sign change. It's subtraction that we need to worry about sign changes with addition and subtraction. Now at this point here, we can combine like terms. We'll have 9x squared. 6x plus 6x is plus 12x. And our negative 1 plus 5 is plus 4 over our 3x plus 2. Questions on this here? At this point here, we need to see if we can factor the numerator. And we can. Now there is no greatest common factor between 9x squared, 12x, and 4. And if we factor it, since the third term is positive, the signs are the same and match the sign of the middle term, plus and plus. Factors of 9x squared, well, our x squared would be x and x. Factors of 9 are 1 and 9 or 3 and 3. If we want something to match up, we're probably going to need the 3 and 3. Because we're trying to match it up to our 3x plus 2. Factors of 4 are 1 and 4 or 2 and 2. We'll need the 2 and 2. And that actually works out to give us our middle term of 12x. And the other nice thing is that we do now have something in common on top and bottom. And one of our 3x plus 2's will cancel on top and bottom, leaving us with 3x plus 2. And that's it. Questions on this here? We'll finish up. We'll start 22